Morning class. Yesterday I posted the walkthrough of the example solution for Excel Solver. Today I'm going to walk through a possible layout for the actual assignment, which is part 4 of the question. And the scenario is that your company has 2 trucks that it wishes to use on a specific contract. One is a new truck and the company is making payments on it. The other is an old truck that's fully paid for. The assignment shows that the per mile basis for fuel of the new truck is that fuel and additives adds up to 54 cents a mile, and the old truck, it costs 60 cents a mile for fuel and additives. The payments on the loan for the new truck, 24 cents per mile. Everything's normalized per mile. The old truck has no payments, so there is 0 payments. The driver that drives this truck is 36 cents a mile he is getting paid. And the old truck uses a less experienced driver at 32 cents a mile. Repairs, again, 12 cents for the new truck, 24 cents for the old truck. Makes sense. The old truck takes twice as much maintenance per mile because it breaks down more often. Miscellaneous expenses, whatever they are a penny a mile for each. So the cost per mile is $1.27 for the new truck and $1.17 for the old truck, which is just the sum of all these cells, so cost per mile. So what you would do is multiply that times the number of miles per truck, which is currently 0 because we're going to use the Excel solver to do that. And what that'll give you is G4 times H4 is going to give you the cost per truck and then the total cost to run both trucks. Now, one constraint was that the total miles in this example was going to be 90,000. So the trucking company decided to do this analysis based on 90,000 that they estimated for this specific contract that would be driven. Another constraint is that they don't want to spend more than $14,000 in repair costs, and that's not just for the old truck, which is using twice as much, but for the new truck also, because obviously it will need maintenance also. So the constraints become the 14,000 and the 90,000. Now remember what I said in the first example solution is that solver doesn't know any more than you tell it, so it needs formulas on what it's going to be looking at. So in this case, you're going to be trying to come up with the least total cost. So this total cost here of both trucks, I4, and what you're going to be variable, what you're going to be changing is the miles that each truck runs, and determining how many miles you want to run each truck to get the least total cost and also not exceed repair costs of 14,000. So obviously the formula needs to know, how do I calculate this? So it has to know that that constraint repair cost is going to be the repair times the miles, and the formula will be for both trucks added together. So repair times miles for the old truck, repair times miles for the new truck. And of course the total miles is just H4 plus H5. So now you're ready to set up the solver parameters. So I will now bring up the solver parameters window that you will fill in, and without giving you the answer for this problem, keep in mind that what you're trying to do is minimize total cost. So whereas in the last example we were trying to maximize profit, here we're trying to minimize total cost. So when you select your target cell, you may want to think about the fact that you're trying to minimize that. And then when you do by changing what variables, remember you're trying to change the miles per truck to determine what the right ratio between one truck and the other should be, and you're subject to the constraints. You would add each one. It would be basically these. And what are you looking for? You're looking for repair costs to be less than or equal to 14,000. But remember, again, 90,000 miles. You're looking for this second constraint to be equal to 90,000 miles, not greater than or less than, because the exercise basically told you we want to do this for 90,000 miles. So I will not go any further with this, but I would like to see how you're able to set that up and how you're able to get the right answer for the miles per truck, the optimum answer for the miles per truck, and then run your sensitivity and limit reports correctly and explain what they indicate. And basically write a rationale statement for what you learned from this and what it's telling you. So it's not just creating data and solving data. It's also analyzing what this data means and what it's telling you. So please don't forget that portion of the assignment. Again, any questions, feel free to contact me and I'd be glad to answer them for you. Fortunately, this graded assignment example right here, to me, is a lot simpler than the example assignment that I posted yesterday, and you only need to submit this one right here, the graded one. You do not need to submit the example. That's just for you to learn from, watch my video, go through the exercise part by part, and learn how to use Excel Solver, which I think is a great tool because, like I showed you in the example, you can tweak these things manually and get an answer, but it would take you who knows how long to optimize the answer by individually selecting where you want to be. I'll give you an example. I'll close this right here, and on miles per truck, I'll say, okay, what if I did 45,000 and 45,000? Okay, that meets my constraints, almost. It gives me repair costs that are too high, but it gives me exactly 90,000 miles, and it gives me this total cost. And then I would say manually, okay, I need the repair cost to be lower, so the old truck better be lower. So I go to 40,000 and 50,000, and I'm still too high. So now I go to 30,000 and 60,000, and I'm still too high. So I go 25,000 and 65,000, and now I'm within, and this is a valid solution because I'm within the repair cost. I have 90,000 miles, and here's my total cost. I have no idea if that's optimized, though. I just know that this is a possible solution, and what Solver's going to do is find the right solution with miles per truck to give me the minimum total cost possible. So like I said, give this a shot. Let me know if you have any problems, and I'd be glad to help you out. Thank you.